All right, so this is the project right here, the cryptography project. You can read through it really quickly. I'm just going to kind of go through an example of how I would go about doing this. So it says cryptography, the study of encoding and decoding secret messages. So part 1 and part 2. So mathematicians that study this field, you can read through this. I'm not going to read all that. Part 1, 50% of your grade. You will create and encode a secret message and send it to me completely worked out. So you can read through all this. This is the Caesar cipher. So I'm going to go through this. Let's start with number 1, the secret message written out. So right here I'm going to do this. We'll count this as number 1. All right, so on a separate sheet of paper, I'm going to go ahead and do that real quick. So the phrase I'm going to use is just space keep space cubing. And this will be part 1. All right, so right there's my phrase, just keep cubing. All right, so the first thing for this we're going to do is we're going to take the Caesar cipher and we are going to put each letter that represents it. So A is 1, B is 2, all the way to 26, which is Z, and 27 is our space. Okay, so let's see. Starting with the J is 10. You know, let's use a different color that way so we can know what's what here. So we know J is 10. Let's keep going. U is 21. S is 19. T is 20. The space is 27. K is 11. E is 5. P is 16. The space is 27. So once again, I'm just matching these letters to these numbers and putting them underneath. C is 3. U is 21. B is 2. That's an I. I is going to be 9. N is 14. And G is 7. So let's just make sure that's good. 10, 21, 19, 20, 27, 11, 5, 5, 16, 27, 3, 21, 2, 9, 14, 7. All right, so there it is right there. Now, so that's part 1. Part 2, or it's still part 1, but part 2 says to take the secret message, convert it into numbers. So part 2 is already taken care of right here. So when I converted this to the numbers, that was the second part that needed to be done. The third part is the secret message has to be written. So this was part 2. Part 3 says the secret message has to be written as a matrix. So for part 3, I'm going to count each one up, and it's going to be 2 rows by however many columns based on what you have. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So since it's 16 numbers, I don't have to round up, right? If it was like 13, I would round to 14. If it was 17, I would round to 18. But since it's 16, I don't have to worry about that. So the third part is going to be to convert this to a 2 rows by, since this is 18, half of 18 is 8. So it's going to be a 2 by 8 matrix. So I'm going to start here. So 10, 21, 19, 10, 21, 19, 20, 20, 27, 11, 5, 5, I think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Had an extra one there. 1, 2, 3, 4. Ah, had 2 20s. So let's fix that real quick. Sorry about that. So do be careful with that. So let's double check that. 10, 21, 19, 20, 27, 11, 5, 5. 1, 2, 3, 4, 5, 6, 7. There are 8 now. Okay. And my second row, starting at 16, 27, 3, 21, 2, 9, 14, and 7. Okay, so now I've converted it to my matrix. So part 3, or step 3, is done. My next one says your specific 2x2 encoding matrix. So if you go up here where it talks about making it, it says create a 2x2 encoding matrix, multiply your code matrix with your encoding matrix. You now have your encoded secret code. Note the determinant of this matrix cannot equal 0. So that doesn't mean you can't use 0. What that means is that the determinant can't be 0, because you'll find out when you do inverses that anything divided by 0 does not exist. All right, so what I'm going to use for mine is going to be this one right here. I'm going to pick 2, 0, 1, 1. Just to show you what the determinant is, 2 times 1 minus 1 times 0 is 2 minus 0, which is 2. So I know my determinant is 2, which is good. Now I did use this one for a specific reason. I used 2, 0, 1, 1 just because the numbers are small. I like to have a 0 in there because when I get to the part 2, it makes it just a tad bit easier. All right, moving on to step 5. Step 5 says, no, let's label this step 4, sorry. Step 5 says to the encoded secret code matrix. So this will be step 5 in part 1. So here we're just going to take our 2x2 and multiply it to my 2x8. So that's step 5. So this is going to be my encoded secret matrix. So I'm going to take this 2x2 and I'm going to multiply it by this over here. So 10, 16, 21, 27, 19, 3, 20, 21, 27, 2, 11, 9, 5, 14, and 5, 7. So there's that there now. All right, from this point here, I'm going to multiply it. So I'm going to actually show you how I'm doing this. So to get the first number here, we do 2 times 10 plus 0 times 16. So 0 times 16. Then I go into the next one. 2 times 21 plus 0 times 27. Then I go into the next one. 2 times 19 plus 0 times 3. 2 times 20 plus, so 2 times 20, 0 plus 0 times 21. All right, I'm going to have to make this a little bit smaller now because I'm running out of space. So 2 times 27 plus 0 times 2. So 0, 21, 0, 2. So 2 times 11 plus, so 2 times 11 plus 0 times 9. And then I have 2 times 5 plus 0 times 14. And the last one is 2 times 5 plus 0 times 7. All right, and that's the end of that part there. Now, for the second part, I'm going to do the same thing. Now I'm doing the bottom row. 1 times 10. This one I'm going to make a little bit smaller so I can fit it in there. Plus 1 times 16. 1 times 21 plus 1 times 27. 1 times 19 plus 1 times 3. 1 times 20 plus 1 times 21. 1 times 27 plus 1 times 2. 1 times 11 plus 1 times 9. Sorry, 1 times 11 plus 1 times 9. 1 times 5 plus 1 times 14. And then we have 1 times 5 plus 1 times 7. All right, and this is our whole thing we're going to work out. So that's just the work behind it. Now, this next part, I'm not going to take my time to work everything out, because if you notice on the top, 2 times 10 is 20, 0 times 16 is 0. So 20 plus 0 is 20. 2 times 21 is 42. 0 times that is 0, so 42. 38 plus 0. 40 plus 0. 54 plus 0. Let's see. 22 plus 0. 10 plus 0. And 10 plus 0. All right, and then we go to the bottom. 10, so 1 times 10 is 10. 1 times 16 is 16, so 10 plus 20 plus 10 plus 16 is 26. 21 plus 27 is 48. 19 plus 3 is 12. Sorry, 19 plus 3 is 22. Sorry about that there. 20 plus 21 is 41. 27 plus 2 is 29. 11 plus 9 is 20. 5 plus 14 is 19. And 5 plus 7 is 12. And let me just verify these numbers. 20, 42, 38, 40, 54, 22, 10, 10, 26, 48, 22, 41, 29, 20, 19, 12. All right, so that all looks good there. So that's the process I would take to get to this answer. So this is all of part 1 completed. So once again, I have my secret message, just keep cubing. I have my secret message converted into numbers right here, 10, 21, 19, 27, all the way through. The secret message written in the matrix, so it was a 2 by 8. My specific 2 by 2 encoding, so I did 2011. I did the determinant, make sure it wasn't 0, because it said to make sure it's not 0. Then I multiplied these two together in step 5, and there is my encoded secret matrix. All right, now for part 2. So this is the other part of your grade on this one. It says you will be given the secret code matrix. And remember, I came up with that myself. This is the secret code matrix. So let's label this. Secret code matrix. So that's my secret code matrix. The 2 by 2 encoding matrix, which is right here. That's my encoding matrix. And the Caesar cipher, which is the same thing from the first part, so this is no different. So it says take the inverse of the encoded matrix. So step 1. Let's go ahead and start here. All right. So this is going to be part 2. So here is step 1. It says to take that 2 by 2 matrix. So how it was for me, it was 2, 0, 1, 1. So if you've forgotten already, that was my step 4. So I had 2, 0, 1, 1. So before I go any further into this, I'm going to remind you of how to find the inverse of a 2 by 2 matrix. It's 1 divided by, you multiply it, so the determinant pretty much. 2 times 1 minus that, times, and this is A, B, C, D, so I'm just going to label these here so you can see what I'm actually going to be doing in a moment. This is A, B, C, D. If you recall the formula, it says with A and D you switch them, so this becomes D, this becomes A, and B and C you make them the opposite. So 0, the opposite of 0 is still 0, so you're not going to make this, if this is A, B, so it'd be negative B, and then negative C. So switch A and D, opposites of B and C. So when I'm finding the inverse here, first thing I'm going to do is 1 over the determinant. 2 times 1 minus 1 times 0. And then I'm going to switch A and D because that's what it's telling me to do. So instead of 2, 1, it's now 1 and 2 here. And opposite of B is still 0. Opposite of C is negative 1. Now to find my inverse, all I have to do is just multiply this out. So 1 over 2 minus 1 is 1. Sorry. 2 minus 0 is 2, so that's 1/2. Okay, so once again, 1 on top, 2 minus 0 is 2 on the bottom. So now, all I'm actually going to do now is multiply these two together, and this is going to give me my my inverse that's going to help me to unlock the Caesar cipher that I need for the other one. So I'm going to multiply 1/2 times 1 is 1/2. 1/2 times 0 is 0. 1/2 times negative 1 is negative 1/2. 1/2 times 2 is 1. All right, so this is going to allow me to decode the other matrix now. So it says take the inverse of the encoding matrix, which I just did. Now it says to multiply the encoding matrix to the secret code matrix. So I am now going to take this right here, and I'm going to multiply it to this right here. So I'm going to multiply these two together. That's going to be my next step. So let's call this step 2, and let's work it out. So for this step, I'm going to write the small one first. So 1/2 0, negative 1/2 1. And if you want to convert it to a decimal, that is really your choice. I just keep it as fractions. Now I'm going to write the big one. 20, 26, 42, 48, 38, 22. So let me make sure 20, 26, 42, 48, 38, 22, 40, 41, 54, 29, 22, 20, 10, 19, 10, 12. All right, and that looks to be good there. Now I'm going to multiply them. So this one I'm not going to, oh yeah, I'll just multiply them. Let's see the work. So half of 20, so I'm going to not show the work here, I'm just going to do it. Half of 20 is 10. 0 times 26 is 0. Half of 42 is 21. Plus, now you see this number is 0, it's always going to be 0 for the second number because 0 times anything here is always going to be 0. Half of 38 is 19 plus the 0 because 0 times 22 is 0. Half of 40 is 20 plus 0. 0 times 41 is 0. Half of 54 is 27 plus 0 because 0 times 29 is 0. Half of 22 is 11 plus 0. Half of 10 is 5 plus 0. And once again, it's 0 because 0 times 19 is 0. Half of 10 is 5. 0 times 12 is 0. All right, for the next part, negative 1/2 times 20 is negative 10. 1 times 26 is 26, so we're going to add those. Negative 1/2 times 42 is negative 22 plus 48. Negative half of 38 is negative 19. 1 times 22 is positive 22. Negative half of 40 is negative 20 plus 41. Negative 1/2 of 54 is negative 27 plus 29. Negative 1/2 of 22 is negative 11 plus, where am I at, 19? Oh, let's see this. Negative 11, 20, sorry. Negative 1/2 of 10 is negative 5 plus 19. Negative 1/2 of 10 is negative 5 plus 12. All right, so that's everything I've done so far. Now, I'm going to simplify it, and this should give me my original. 10 plus 0 is 10. 21 plus 0, 21. 19 plus 0, 19. 20 plus 0, 20, 27 plus 0, 27, 11 plus 0, 11, 5 plus 0, 5 plus 0, 5, and 5. Negative 10 plus 26, 16. Negative 22 plus 48 is 26. I think this was negative 21, actually. I made a mistake there, sorry. Yeah, because half of that should have been negative 21. Okay, so that's 27, actually. Because I know I didn't use a z, so sorry about that small error there. Negative 19 plus 20, let me see where I'm at. 16, 27, negative 19 plus 22 is 3. Negative 20 plus 41 is 21. Negative 27 plus 29 is 2. Negative 11 plus 20 is 9. Negative 5 plus 19 is 14. Negative 5 plus 12 is 7. So let's see if we can do this now. So bringing back this little thing here. So I'm looking at this on the side. So 10 is J. 21 is U. 19 is S. 20 is T. 27 is a space. 11 is K. 5 is E twice. 16 is P. 27 is a space. 3 is C. 21 is U. 2 is B. 9 is I. 14 is N. And 7 is G. And there you go. So all that work, so I encoded it and then I decrypted it, and the code did work out. So when I multiplied it all out, it came to this, which if I compare it back to my original, they should be the same. 10, make sure you can see this. So it was 10, 21, 19, 20, 27, 11, 5, 5, 16, 27, 3, 21, 2, 9, 14, and 7. So this is all the work you'd have to show to get full credits.